Factem's R&D team is composed of 20 people, from technicians to senior engineers or doctors. Our three main areas of expertise are acoustics, mechanical engineering, and electronics.
In terms of acoustics, we are specialized in the design of not only the electroacoustic equipment, like for example the microphones, the transducer or the receiver, but also on the complete systems, which can include, for example, active noise cancelling or wireless transmission. And in order to develop all these kind of new solutions, Factem acoustic team has test equipment and specific environment, like for example artificial mouth, artificial ears, and HAT, which is a head and torso simulator, but also a reverberant room and anechoic chamber.
Factem develops all its electronic boards and embedded software internally, so that all the know-how is always available for new challenges. In addition to common electronic lab equipment or development software, our teams are made up of highly skilled technicians that can prototype SMD board in a very short time. Our skills include analog, digital electronics, electromagnetic compatibility, audio processing, 3D sound, telecommunication, and more, all of which can help us in addressing all kinds of functions and processes.
Our products are designed by our mechanical engineers on the latest CAD softwares. For the last few years, 3D printers have extensively been used by the team to accelerate iteration loops in collaboration with acoustic engineers. Simulation tools are also used to ensure the robustness of our designs over time. The design can then be qualified in time through testing on a fatigue bench.
Factem's research and development team works on two main types of products, those based on Factem's own specification and those based on our customer specification. Our technical skills associated to our development tools and test capabilities allow us to develop and create various acoustical devices, from simple transducers to a full headset with active noise cancelling to handsets, loudspeakers, and so on, for aviation, military applications, but not only. Projects are led by a team of project managers that follow processes that complies with the latest aviation and military standards, and this ensures a consistent quality for our entire project portfolio. Today we are able to develop on-demand products such as a wideband acoustic response with an ingress prediction of 67, and the acoustic quality that we reach today can compete with the best audio manufacturers. In addition to project development, the R&D team works on innovation projects in various fields. One of them is the search for a better acoustic experience for the cockpit crew, with features such as a speech denoising, sound spatializations, or innovative human-machine interface. Finally, Factem is also involved in larger scale projects such as the development of a advanced solution for patient monitoring in medical applications, or for the development of a wireless audio headset that uses light instead of the conventional radio waves.
Today, pilots of large aircrafts use wired headsets to communicate with the cockpit crew, the cabin crew or the air traffic control. They could use wireless headsets, but so far all the available solutions rely on RF technologies such as Bluetooth, Wi-Fi. The problem with those technologies is that they are known to be unsecure. The signal can be jammed or eavesdropped. On top of that, they are subject to electromagnetic interferences. Those drawbacks seriously limit the use of such conventional technologies in an environment such as a cockpit where security and safety are paramount. To overcome those issues, the ALC project aims at using a technology based on light, which is called Li-Fi, that stands for Light Fidelity. The ambition of the project is to bring evidence that this technology is suitable for a cockpit environment. To do so, Factem is associated to a French laboratory, XLIM, and a Scottish company, Pure Li-Fi, to develop 3 prototypes to be tested on a cockpit simulator: an audio headset, a tablet or electronic flight bag that is used to display flight charts, procedures and more, and a headset equipped with physiological sensors. The main challenge that we have is that we have to design those prototypes so that they fully work in every position in the cockpit, whatever the light conditions, either at night or during intense sunlight, or even in the presence of smoke. On top of that, we should ensure enough autonomy to ensure a long-haul flight, which lasts about 12 hours. Lastly, the really critical challenge is for the headset, where we want to reach an audio latency as low as 2.5 milliseconds. This project brings a lot to Factem and the other partners. It's a very exciting project with high added value and opportunities. We really wish that those prototypes will be tested during a real flight test.